Hello everyone, welcome to the online video tutorial series of computer network subject. In this video, I will explain about the routing algorithm concept with the help of Dijkstra algorithm. I am Nishan, Assistant Professor in IT/ICT Department of LJ Institute of Engineering and Technology. So let's start today's topic. So in this video, I will cover routing basics, how the exactly routing process is performing, what are the types of routing, and routing algorithm basics and Dijkstra algorithm. So now let's move to the what is the exactly routing process. So when we are talking about routing, so it is the process of selecting path in a network along which we want to send our data packets. So the goal of our routing is to achieve the correctness, simplicity, robustness, and stability for the finding natural or dynamical path for finding the best or optimal one to send the data packets to the destination. For that, different routing algorithms are used with the help of broad category. That category are based on static or dynamic, or distributed or centralized, single path or multipath, flat or hierarchy, intra-domain or inter-domain, and link state or distance vector. So these are the broad category under different various routing algorithms are used. That algorithms are performing the task according to its property. So how that particular algorithm are performing, that will be in detail part. Now we are moving how exactly routing is performed. So when we are trying to send the data packets from our network layer, so first that data packets are encapsulated. In that encapsulated packet, our payload and header information is available. Now, when the data packets trying to send from our source to destination, it will travel from multiple routers. So how that next hop will be calculated? For that, two mechanisms are used. First is routing mechanism. In that, we are performing the forwarding mechanism. So routing mechanism is performed by the different routing algorithms according to this category. So when we are talking about routing algorithm, it determines end-to-end delivery. So how exactly our data packets are forwarding from source to destination, that is determined by our routing algorithm. And when we are talking about forwarding table, our forwarding table is determined how the local particular data is forwarding from one hop to another hop. So it identifies the addresses which are belonging to the next hop, and for that which incoming and outgoing links are maintained. So when we are talking about exactly forwarding table, then forwarding table contain addresses of the next hop, incoming port and outgoing port. That is the interfaces for incoming and outgoing of that packets. So each and every router is maintaining this type of tables, and that tables are maintained by the different routing algorithms. So routing algorithms is basically categorized in non-adaptive and adaptive routing mechanism. So when we are talking about non-adaptive mechanism, then it must take the data on the static base. That data is maintained by network administrator. So some specific path will be defined. Using that path, our data packet is moved. So it may be centralized or distributed. But when we are talking about adaptive routing algorithm, it will use the flooding type of mechanism that is used dynamically. Dynamically, which path is introduced, which is optimum one or new one that is adapted by the router. So non-adaptive is predefined to follow the path, where when we are talking about adaptive routing algorithm, it will identify the dynamic approach. So for that particular category, we can use different algorithms. So we can use shortest path algorithm, distance vector, or link state. So when we are moving to the shortest path, it will take the minimum distance from the particular node to the adjacent nodes. The neighbor nodes from reaching from source to destination, which will be the minimum that will be considered by. Next one is distance vector. So distance vector, we can use Bellman code or RIP. RIP contains different version that will be revived into the RIP form. So basically in this video, I will try to cover our first part, that is all about Dijkstra algorithm. Now, Dijkstra algorithm is basically use the networking topology that consume the link cost that known to the all nodes. So here each and every link is broadcasting the cost from the particular node. What are the cost to reach the particular neighbor? That neighbor information, costing information are flooded to the whole node. That nodes are computed and that computed values are updated into the table. So here we compute the cost that is least. From that we can reach the particular data item. So these things will be calculated iteratively till that our data is reaching to the destination. So from source to destination, if we have multiple options to reach that destination, so which one contains the minimal cost, that will be identified the Dijkstra algorithm. So for this understanding this algorithm, we have to understand these simple notations. So this notation is first is all about C of xy. So C of xy is identify the link cost from our node x to y. So suppose if we can reach x to y, then we can put the value of cost. But directly if we cannot reach x to y, then we have to put infinite here, because in Dijkstra algorithm we always take care about the neighbor node. We are not targeting the all the nodes simultaneously. Now next notation is D of V. So D of V is all about current value of cost of path from source to destination V. Next is P of V. So when we are talking about P of V, it is take care about the predecessor node, from which path our source can be reached to the particular destination, that is all about P of V. And the last one is N dash. So N dash set is all about set of nodes whose least cost path definitively known by the particular neighbor node. Suppose if you want to move to x to y to z, then which are the path using through we can go, that will be identified by N dash. So let's move to the algorithm and steps of Dijkstra algorithm. So first we are starting from the initialization. So consider here N dash. In that we are considering the set, it is U. So we can consider V is our source, U is our source, and V is our destination. So here from U we are identifying how many nodes will be calculated directly. So for all nodes we have to use this particular loop. So for all node we have to calculate till V. V is our destination. If V is adjacent to U, suppose destination is directly reached by our source, then we have to calculate direct the cost. So calculate cost of U of V is equal to D of V. So if from U we can reach directly destination V, then we are directly taking that cost as our D of V. But if we cannot reach that particular value, then we are putting here infinite. So if source to destination we have a single link, then we can put the cost. If it is not available, then we can put here infinite. Now next, if you are not getting the destination value directly, then we have to calculate hope by hope. So for that following steps are used. So we have to find the W. So W is our intermediate node in our N dash. N dash is our set of the particular nodes from where we can reach the particular destination. So here we have to add N dash and update our DV here. So here D of V is our adjacent node from where we can reach to the N dash. Now we have to choose which cost is the minimal one. Okay, if we can reach to the particular V using direct V and from DW plus cost of CW. So from that, if we are finding the minimum cost, that will be considered as a cost of D of V. So here D of V is all about the cost of reaching our destination. So from that we are finding how we can choose the shortest path from source U to V via W. And that steps will be calculated for all the nodes, and that nodes will be added to our N dash. That is the set of our adjacent nodes. Now understand this algorithm with the help of example. So here See the particular diagram U, V, W, Y, Z and X. These are the our particular nodes. Now our goal is to reach from U to particular destination. Now for that we are calculating this particular table. So here in step number 1 we are putting here source node U. So from U we can reach 3 holes X, W and V. So here adjacent nodes are our X, W and V where we can reach directly. So we can put the value. So from U to X I can reach via 5 value. So I am putting here. Next is U to W. We can reach with the 3 value. So we are putting in this. And from U to particular data item X we can reach for 7 value. So all 3 values we can put. But from U we cannot reach directly Y and particular Z. So that values are infinite. So in first number this step we are putting the values from where we can put directly the value, that is 7U, 3U and 5U. Remaining are infinite because we cannot reach directly. Now from this we are taking the minimal one. So here distance of W is the minimum from 7, 3 and 5. So that will be considered as a minimum one and that will be a set of endless even. So next our root will be U of W. Now our root will be fixed here. U to W we are not going here X and V. Okay. So from particular W how many nodes we can visit? Yes, from W we can visit X, Y and particular data item V. Okay. So from that we can calculate the data. So in particular first step we can reach particular data item using 7 data items. But if we are following the path of W, then data item will be updated with 3 plus 3, 6. Okay. Now it is up to updation of first node. How can we reach to the V from our U? Now we are moving to the next one. How can we reach particular X? Suppose we are moving from U to W, that is 3. Then W to X, that is 4. So 3 plus 4 is 7. But we can directly reach U to X, that is 5. Okay, so we have to maintain the minimum cost. That's why we are putting here 5. Now from W we can reach here Y. That cost will be 3 plus 8, that is 11. But from W we cannot directly reach to the Z. So we are putting here infinite. Now in step number 2 we can say that our minimum value is our phi of Q, that is eligible for X. So our data item will be U, W and X. Okay. Now calculating for that particular U, W and X. From X we can reach all data items, that is Y, Z. Okay. So we are updating the value from particular data item, the VW, we can use the 6 value. For that particular Y, we can reach here via X, that will be 3 plus 4, 7 and plus 7, that is 14, that is maximum one. Again if we can go 5 plus 7, that is 10, that is greater than 11. So we are maintaining the data item with the value 11 here. But we can reach here Z. So here the value will be our 5 plus 9, 14. Next value is 3 plus 4 plus 9, that is 17. Okay, but from that we are taking the minimum one, that is a 14 value. Now from the step number 2 we are taking the minimal cost, that is all about V. So our next data item will be U, W, X and V. So we can reach our data item via this route, that will be U, W, X and V. Now for the finding minimal cost for our Y and Z we are calculating the data. So for that we are choosing the particular path, that is U to W, that is 3, W to X, that is 3 and from that we can reach to the Y. So that is 3 plus 4, that is 10. But if we are checking the previous value, that is 3 plus 8, it is 11. So we can maintain the here path, that is U, W, X and Y. That is the minimum case to reach the particular data item Y. So we are maintaining a 10 data item here, and for 14 we are not directly reaching that, so we are maintaining the previous value, that is 14. Now so our next path will be V, W, X, Y and X, V and Y. Now we are performing this path and performing the last operation to reach the data item Z. So for that we are maintaining the path, that is 3, that is u to w, then w to y, that is 3, then y to v to y, that is 4, 3 plus 3 4, 3 plus 3 6, then we are adding 4, that is 10, and then y to z, that is 2. So that is total is 12. So previous what we are performing here, 5 plus 9, that path is u to x and x to z, that is the minimum case of 40. But here if we are performing this path, we are maintaining the data, that is 12, that is the minimum. So our final result will be our u, w, x, v, y, z, how we can reach to the destination with the minimum cost. So according to the Dijsktra algorithm, we have to share the data to our neighbor nodes. That neighbor nodes having the direct connection, then we are putting the value. If they are not reaching, then we have to put the infinite. And after each and every iteration, we are flooding the values. If that data values are minimum than previous one, then we are accepting, otherwise we are discarding. The flow will be continued to the next last node, and we are finding the minimal cost. So this is all about how the Dijkstra algorithm is working. So thank you for watching this video.